we talked about folded soak filter. So for folded soak filter, we have this arrangement. Positive row, negative row, positive row, negative row, positive row, negative row, P1. Okay, a folded soak filter consisted of one polarizer, one analyzer, and a lot of wave plates in between. Okay, the wave plates are arranged like this. The first one, the orientation is positive row. The second one is negative row, and then positive, negative in pairs for many periods. Okay, and totally we have m period, m period. Or n pieces， 就是我们有 n 块wave plate 然后呢每两个凑成一对那总共一对就是一个周期one pairs one pair is one correspond to one period. Okay, so totally we have m period. So n is equal to 2m. Okay. The matrix representation of a pair of wave plates can be written as W minus rho times W rho. Okay, and I denote this as capital omega, and then the matrix corresponding to all the wave plates is the nth power of capital omega, okay, which is this W minus rho times W rho. Okay. Here W rho means R minus rho times W0 times R rho. Here W0 is this exponential minus half gamma 0, 0 exponential I half gamma. Okay, and R rho is the rotation matrix of corresponding to the angle rho, rotated by angle rho. This action is represented by the rotation matrix cosine rho, sine rho, minus sine rho, and cosine rho. Okay, and then you multiply these three matrices to get W rho and replace rho by minus rho, you get the matrix W minus rho. Then you multiply W minus rho with W rho, you get capital omega. And finally, you calculate the nth power of capital omega. There is the so-called Chebyshev identity. Chebyshev's identity means that the nth power of the capital omega is equal to sine of m theta over sine theta times capital omega minus sine m minus 1 theta over sine theta times unit matrix. Here, theta is defined as arccosine 1/2 trace capital omega. Okay. Trace means that sum over the diagonal term of the matrix. You can also write this as cosine theta. Cosine theta is defined as 1/2 trace omega. Okay. In the textbook, the author denotes this capital omega as A, B, C, D. This identity is correct in the condition that determinant omega equal to 1. Okay. We must have this property to derive this result. Okay. This can be easily proved because the determinant W rho is equal to determinant R minus rho times determinant W0 times determinant R of rho. Okay, and all of this are 1, 1, 1. Okay, the determinant for R minus rho is 1, determinant W0 is 1, determinant R rho is 1. Okay, so this is 1. And also determinant W minus rho is also 1. So determinant omega is 1. Okay, so once you have this property, you can denote the eigenvalues of omega as lambda 1, 2 equal to exponential plus minus I theta. And how about the trace? Trace means sum over the diagonal terms of the matrix. However, the trace of a matrix is just equal to the summation of all of the eigenvalues of the matrix. Okay， 那所以呢，这个加在一起就是什么呢？就是 exponential I theta 加 exponential 负 I theta， 就是2倍的 cosine theta， 所以除以2之后就是 cosine theta。OK， 啊 ，this property tells us that we have two eigenvalues. Eigenvalues 2 is the inverse of eigenvalue number 1. Okay. So if I denote the first eigenvalue as exponential I theta, then the second eigenvalue can be represented by exponential minus I theta. Okay, and then when I sum over the two eigenvalues, I get double cosine theta. Okay, and linear algebra tells us that the trace is invariant under similarity transformation, which means that the original trace of the matrix is equal to the summation, the sum of lambda 1 and lambda 2. Okay, so trace omega is just equal to lambda 1 plus lambda 2. And the lambda 1, 2 are exponential plus and minus I theta, so the summation of them is equal to 2 cosine theta. So divided by 2, we get cosine theta is equal to 1/2 trace omega. OK， 好，所以这整个逻辑上都很清楚啊。然后你现在再把它用 A、B、C、D 矩阵写出来啊。Then now you write out the result in the specific expression A, B, C, D. Then you get the nth power m of n is equal to this a times sine m theta over sine theta minus sine m minus 1 theta over sine theta. Okay, and here d sine m theta over sine theta minus sine m minus 1 theta over sine theta. And here b sine m theta over sine theta. And here c sine m theta over sine theta. Okay, and by calculation you can find that c is minus d. Okay, and you can do this multiplication to find the result of A and D. OK， 好，这个是关于这个计算。现在我们要来分析 transmission 或者 transmissivity。In the textbook, the author used the notation k lambda to denote this theta. Okay. Here I use the notation theta, but in the textbook the author used the notation k lambda. Here lambda means the period. Lambda is the period. This is one period. The width of one period is denoted as capital lambda. Okay. Then you can introduce some kind of wave number. This wave number is the so-called block wave number. Why call it block wave number? Because in periodic arrangement, waves or polarization states revolve according to so-called block theorem. Okay. 就像半导体或者是固态物理里面告诉你说，电子在这个周期位能里面，这个传播的时候，它的波函数是一个所谓的布洛厄波的形式。那这边的情况其实也是一样那这个东西的这个证明的话，可能需要 一点，其实不用特别证明什么，就是我只要把这个叫做 k 浪大就好了啊。然后呢，这个东西就是 exponential k 浪大哈，这就等于是布洛赫定理啊。那只是说你这边可能对它还没什么感觉哈。我们假设有机会教第6章的话啊，会讲到这个一维光子晶体之后，会再进一步跟大家解释这个所谓的布洛赫定理哈。If we have chance to teach chapter 6, then I will explain to you what the bulk theorem is. 好，那到这边为止呢，下一步就是我们真的要去计算这个 transmissivity 啊。So the purpose of all this complicated calculation is that we can do some analysis about the transmissivity of the wave plate. Before doing that, we can find some very special role so that we get the transmissivity equal to 1. Okay. Suppose we consider the situation that 我们先找出很特别的伽马跟很特别的 rho， 然后呢再去分析说如果稍微偏离它一点会怎么样啊？那这个很特别的伽马跟很特别的 rho 会给出 transmissivity equal to 1， 就是说光完全穿透啊。First we analyze some very special gamma and very special rho so that we get transmissivity equal to 1. Then we study the transmissivity around this very special gamma, okay? Because we can vary the wavelength. Once we fix the rho, we do not change them, okay? However, we can change the wavelength, okay? So consider the special case that gamma is equal to pi, half wave plane. Consider let's consider gamma equal to pi. Then, if we want the transmissivity equal to 1, how to do this? You see that the effect of the orientations of these wave plates, I have already analyzed the situation that suppose the slow axis, fast axis of the wave plate are denoted as S and F. The angle between them is 90 degrees. And suppose we initially has the polarization parallel to the x-axis. X-axis. Then, since I have explained that you can you can write the original polarization as, say, okay, say 我叫它什么才好呢？好 ，ES times ES， okay, plus EF times EF， okay。假设原来电场的振幅是1，沿 x 方向，可以把它分解成两个分量啊，沿着 slow axis 跟沿着 fast axis。Okay, originally we can write the E vector, the original E vector can be written as the summation of ES times the here ES means the unit vector along the slope axis, and the EF means the unit vector along the fast axis. Then after penetration through the halfway plate, we have a very simple way to analyze the result. The method is that we keep the component along the s-axis to be unchanged, then give a minus sign to the other component along the fast axis. So after penetration through this wave plate, the E vector becomes E prime. E prime is equal to some unuseful phase factor, say exponential I alpha, times 这边的 I alpha 呢，其实是什么？其实就是 I 了啊，其实就是 minus I 了 ，minus I times ES minus EF. Okay. So after penetration through this wave plate, this phase factor is use this. Okay. We just see this effect here. The fast component gets the minus sign. This means that now the component becomes. This component becomes reversed. So the summation of them, the final E vector, this is the original E vector, and this is the final E vector, E prime. The angle between x-axis and the slope axis is psi, which is also the angle between the original E vector and the slope axis. Now the resultant, the final E vector, the E prime, the angle between E prime and the slope axis is also psi. Okay, so this means that the original E vector being rotated to psi. So the E prime is obtained by rotating the E vector to psi. Okay, if the wave plate is half wave plate. So this means that now psi is equal to rho. So originally we have angle equal to 0 because along the polarization is along the x-axis. Then penetration through the first wave plate, the angle becomes 2 rho. Okay, and then minus 4 rho, and then positive 6 rho, and minus 8 rho. The reason is that这个是 rho， 这个是 rho 然后现在呢，接下来那一片呢是在负 rho 的地方，但是负 rho 跟正2 rho 加3 rho， 所以会往反方向再甩一个3 rho， 就会从负 rho 再减3 rho， 就变成什么呢？就变成负4 rho 了 ，OK， 就变负4 rho 了。那负4 rho 呢，再跟正 rho 加5 rho 嘛，然后呢就会往正 rho 的上面再甩一个3 rho， 5 rho 甩一个5 rho， 就是正 rho 再加5 rho 就变成6 rho，OK， 所以就会这样子，正负交错，然后数值是0、2 rho、4 rho、6 rho、8 rho 这样子过去So finally, we have for one period we get minus 4. So for m period we get minus 4m. Okay, minus 4m rho. 好，但是这个正负号不重要了，因为你偏正的跟反的其实是同一个偏正的哈。差一个负号只是一个 face 同一个偏正，所以意思就是 so finally 4m rho or 2m rho is equal to half pi. Okay, so this means that rho is equal to pi over 4m. Okay, so if we choose the wave plate to be half wave plate, and if we hope the transmissivity to be equal to 1, then we choose rho to be pi over 4n. OK， 好，所以在这个情况下呢，当我选 rho 是 pi over 4n， 然后伽马是 pi 的时候，它的 transmissivity 会等于1，会等于1。好，当然这里有一点假设，就是说我昨天说过，我们把反射的部分都忽略掉If we ignore all possible reflection mechanism, we can treat the W matrix as so-called unitary matrix. Okay, unitary matrix means that we change the polarization state of the E vector without changing its magnitude. Okay, 好，然后呢，如果我选择伽马是派的时候，那我选择 rho 是这样的，然后就会得到什么呢 ？T 等于1。We can check this result by using our final formula. This is because we can write down the transmissivity formula by noting that I write the original E vector as EX, EY. And first of all, it encounters the polarizer along the X direction. Then it encounters the whole series of wave plates. And then it encounters this polarizer along the Y direction. And finally, we get the EX prime, EY prime, the E prime vector. Okay? And suppose I write the final result, the M matrix as M11, M12, M21, and M22. And we know that Px is 1, 0, 0, 0. And here we have Ex, Ey, and this is equal to 0, 0, 0, 1. Okay? And then the result is this times this 0, 0, M21 and M22. And this times this gives us Ex 0. Okay? So the result is 0, M21, Ex. Okay? This means that Ex prime is equal to 0 and Ey prime is equal to M21 times Ex. Okay? This is trivial because we use Y polarizer, so we have no X exponent of the E vector. And the Y component of the E vector is equal to the matrix element M21 times Ex. However, what is M21? So, if we want to calculate the transmissivity, it is equal to Ey prime absolute square over Ex absolute square, okay? And the result is the absolute value square of M21. However, what is M21? M21 is this. M21 is C times sine M theta over sine theta. OK， 这个就是所谓的 M21。那什么是 C 呢？ So what is C? C is minus B, which is equal to sine 4 rho sine square half gamma. Okay, I have already tell you that the textbook has a typo. Okay, in the textbook, the author write B as sine 4 rho sine square half gamma. But in fact, B is the minus, the negative sign of sine 4 rho sine square half gamma. 就课本上的差了一个负号。但是 B 跟 C 的关系是仍然是C 等于负 B， 这没问题。But the relation between C and B is still this. C is minus B. Okay. So we substitute this here. Sine 4 rho sine square half gamma times sine M theta over sine theta. You can calculate the result use computer code. Okay, that's no problem. But we want to analyze the behavior of this function when we see the point very close to the peak of this t function transmissivity function 我们先看一个特殊状况在看那个特殊状况之前呢，我们先需要做一件事情就是我们要找出这个 theta 的表达式这个是稍微需要一点计算但这个计算的话呢，就是你自己算就好了So, in the textbook, the authors have already listed the A, B, C, D vector. A, B, C, D are listed in equation 5.3-3. Okay. So, use this result, you can find that cosine theta is 1/2 trace capital omega is the summation of A and D. 1/2 A plus D. So you use the result in the textbook about A and D, you can find the result 1 minus 2 cosine square 2 rho sine square half gamma. Okay. This structure looks like something of this. Cosine 2x is equal to 2 cosine square x minus 1 or 1 minus 2 sine square x. Okay? So,我把这个叫做叫 x 也可以，叫开也可以So if you compare this structure with this formula, you will find that this structure is something like this. Or you can identify it as pi minus 2x. If we include 1 pi, then this can also be written as this. 因为我们把它换成加或减一个派的时候，它就多一个负号就多一个负号。So the author used this transformation. The author defines this pi minus 2 开这边他用了开这个符号，开长得很像 x 但它跟 x 不一样x 是英文字母，开是希腊字母Here we use the notation chi, okay? we define theta as pi minus 2 chi. Then we find cosine pi minus 2 chi, okay, is equal to minus cosine 2 chi minus cosine 2 chi, and the result is equal to 1 minus 2 cosine squared chi. And compare with this 1 minus 2 cosine squared, not cosine, cosine squared 2 rho times sine squared half gamma. Okay? So you see that now we have this relation. We now have cosine squared chi equal to cosine squared 2 rho times sine squared half gamma. Okay? So I can write the result as cosine chi is equal to positive or negative cosine 2 rho sine half gamma. 那课本是直接用了正号，但我这边呢，我想把正负号都保留，因为我们等一下会看到，有时候会需要用到负号。OK， 好 ，Here I keep this positive or negative sign here, because it is more convenient for us to analyze our result. This is the formula in the textbook 5.3-13. Then if we use this formula, then t can be represented as the square root of sine square sine 4 rho. We can write sine 4 rho as 2 sine 2 rho cosine 2 rho. This is sine 4 rho. Okay? And times sine square half gamma. And how about m theta? Okay, sine m theta. Since theta is equal to pi minus 2 chi, this is equal to sine 2m pi minus 2m chi. Okay. However, when we add integer times 2 pi to the argument of sine and cosine, we can just ignore it, okay? And this, and 2m is equal to n, so this is equal to minus sine n chi, okay? Minus sine n chi. And this is equal to sine pi minus 2 chi, which is equal to sine 2 chi. Sine 2 chi. And this is equal to 2 sine chi cosine chi. Okay? So this result is minus sine n chi 2 sine chi cosine chi. Okay? But inside the absolute value, we can ignore the positive and negative sign here. So we can ignore this because inside the absolute value sign, and we have square. And since now we have this, here we have 2 sine half gamma. Okay, so this factor can be written as cosine 2 rho times sine half gamma times sine half gamma. Okay, and this part can be replaced by cosine chi. Okay, so this can be replaced by cosine chi sine half gamma. Okay. 我这边为什么不用等号而用箭头符号？因为这边还是有可能差一个正负号，但是没有关系，因为在这个绝对值里面，正负号没有作用。OK， 好 ，so this part can be written as this. So finally, this is equal to, here we have 2 sine 2 rho, okay, and cosine chi times sine half gamma, okay, and sine n chi 2 sine chi cosine chi. 再给我1分钟。And here cosine chi cancel with cosine chi. However, and the 2 cancel with 2. However, here we have sine 2 rho. Sine 2 rho is equal to sine 2 sine rho cosine rho. 应该这样想吧，不是？下啊。Here sine 2 rho can be written as this sine 2 rho over cosine 2 rho times cosine 2 rho sine half gamma, okay, times sine n chi over sine chi. And this is cosine chi. Okay, this can be replaced by cosine chi. And how about this? This is tangent 2 rho. Okay, so finally we have this. T is equal to tangent 2 rho cosine chi times sine n chi over sine chi absolute square. 好，我们就在这边先暂停一下。好，我们在这边下课。